Is that the Kubernetes logo behind you? Oh, darn, that's on the recording.
All right. Welcome everybody to another working group batch meeting. Today is April 25th, 2004. Just a quick reminder we are recording and you should be abiding to the Kubernetes Code of Conduct. Um, with that said, let's move into the agenda. If I can find the share screen button. Yes. So, let me start with a quick FYI. Every year we have to publish a report for every SIG and working group. Maciek just open up this pull request that contains the report. So if you have any input for it, feel free to leave some comments. But it's rather simple, just a summary of what we achieved in the last year, both in terms of feature sets and organization matters, or anything we have achieved in the ecosystem. So with that, I think we can move to the second topic. Vanessa, you can take it away. Do you need to share your screen, or you want me
Yeah,
to?
I can share my screen. I think that might be easier to look at some, basically a consolidated thing. Give me 1 second to find all the buttons. Oh, it says it's disabled.
I have to make you a co-host. Okay, it's done.
Alrighty, you can see my screen. I'm going to leave myself unmuted so that I don't have to deal with Zoom controls. So to kind of step back, I work at a national lab. I'm from the HPC land universe, high performance computing. And what we started to notice last year is that there's a lot of kind of complementary terms that are used in both namespaces, such as batch, such as scheduling. And actually, Aldo, one of these early things happened with you where we might say the same term. And sometimes we're talking about similar things, but a lot of times we're talking about entirely different things. So the example with Aldo is that I was talking to you about a service. And I kept saying service, service, and I was talking about something with an API, and Aldo was like, Vanessa, you cannot call that a service. We have a thing in Kubernetes that it is a service, and it is absolutely not that. And this kept happening with things like batch, for example. Last year, there was an initiative, let's define what batch is. And I was like, now hold on now. We've been doing batch stuff in HPC for decades now, predating like my life. So why are we coming up with new definitions? And so there's this general need to come up with this converged space of terms. So this place between cloud and HPC where we can talk intelligently about some of these designs and architectures. For example, if we're working on custom schedulers, and we have some confidence that we're talking about the same thing. So this idea was to come up with this, I guess we're calling them converged computing lessons. I started collaborating with some folks on I think one of the Kubernetes product management teams at Google. I don't know if they were in a meeting previously, Ali and Mofi. I don't know if folks know them at Google. And we started collaborating with them. Their bandwidth was a little low. And so the idea was to kind of bring it out to the general community. So what we have here are basically this list of definitions that have been shared. A lot of you have already given feedback. That's really great. There's some discussion here on HTC, high throughput computing versus high performance computing. But the basic idea is that we want to kind of get these definitions down to something generic that could really well describe what it is in kind of both landscapes. And then we want to go, the goal of having these terms is then we can go into kind of more advanced discussions. So something that I want to talk about are, for example, patterns of job design. Let's see, did I talk about that? There's another, yes, this one here. Let me just quickly show you this document. Because I think, oh no, this is the wrong one. Wrong document, abort. Let's go back to my under here. Job patterns. Okay, yeah. So I think this is something that I'm seeing emerge in the Kubernetes landscape, and it's really interesting when you talk about patterns of job signs. So job set is a very simple example. This new leader workers design that has this launcher workers patterns. There's other things to talk about like state machine, nested hierarchy, tightly coupled pattern. I think it would be easier to develop and to be able to define these patterns of jobs, put projects under them. So the basic idea is to come up with these terms. And what I've been working on is I'm going to be making, this is just running on my local machine, so it's not public anywhere yet, but basically this converged computing site is going to be hosted on GitHub, so you can, contribute to it very easily. And this is going to be basically where we have a lot of these terms that talk about these things. And I'd like to grow this into a larger resources that kind of introduces and talks about the terms, but then links to projects. I'd like to also make some videos and make it a larger kind of community oriented thing. And that is the extent to what I've done so far. My plan is to probably finish this particular the set of definitions. I think we're almost done, but then this should come on in maybe the next month and a half or so. So let me pause there and see if there are any questions about, I guess, either the high level idea or specific terms or anything at all, really. Oh, I'm not seeing the chat. More chat. Nope, nothing in the chat.
Maybe me. So I guess the idea is to have some form of glossary of the terms that researchers that are used to. Is it are these terms specific to a particular framework like Slurm, or are these more
So
generic?
I'm hoping the answer is no. So like I think what we could do is we could talk about different terms in the context of different landscapes. So for example, talking about scheduling in Kubernetes is going to be a different conversation than talking about scheduling for Flux. And I think that was one of the original design documents that I opened. The kind of thing that I started working on is actually kind of specking out. What I wanted to do is spec out, for example, the design of what in Flux we call a scheduler versus what in Kubernetes is called a scheduler, and then to really try to understand how those components map between spaces. Because from a research and a work perspective, if you want to do something like take a component of your HPC scheduler and figure out where it fits in the Kubernetes landscape, this is the kind of mapping that you'll need to do and you'll need to understand. So to answer your question, it's terminology, but it's terminology that's going to inform a larger landscape that will include being able to kind of drive projects and research and better discussion and collaboration and communication between our two communities.
Okay. And is your input entirely from the comments you got in the doc, or are do you expect people in this group to provide
Yeah,
reviews
so
to
so this
to
is like
the
a long document, right?
Mhm.
I'm not expecting people to like read through it in miraculous speed and give comments right now. It's more right now of kind of asynchronous feedback. So I think we shared it in the batch working group channel. If you haven't gotten a chance to look at it and give feedback yet, please, there's still time and due. I'm also been sharing and presenting for the other batch working group in CNCF, which is incredibly confusing that there's two of you. But yeah, right now it's sort of getting feedback. It started sort of with a few teams at Google, a few teams at the lab, and then we've opened it up to sort of be the larger community. And my hope is that once it's on GitHub, then well, it's in open source land where we can kind of, as we're working on specific things. So for example, let's say that a next stage is to be like, okay, let's really talk about scheduling components. Let's talk about queue. Let's talk about the default scheduler. Let's move into how to, one issue that's I've seen a lot of activity on is like, how do I write a default scheduler plugin? This is not clear. It is hard. This is something that we could work on kind of through this setup, if that makes sense. So my goal is, I think our goal is to kind of start with the basics, start with kind of defining the landscapes via these terms, this terminology, and then to expand it out to meet all of these different sort of use cases which are they're technical in the sense that like we want to work on technical projects, but they're cultural in the sense that it's going to help with understanding that's needed in order to do that.
Yeah, I think this is great and well needed because I know I've talked with some people at supercomputing, and I think generally the use of scheduler is it's very common. I mean, everything, and then like workload and like workflows and workloads are very different. And then I'm sure if you're coming from the machine learning side, it might be a pipeline, and all this is kind of helpful to sort of get everyone on the same page. I know that my previous team also was thinking about this at one point.
Mm-hmm.
So, yeah, I mean, when you have it up, I think I had some comments on here, but mostly I was just uh, word vomiting, to be honest.
Word vomiting.
But
That's one way to put it.
yeah, I think the thing is I find interesting. I'm seeing in the HPC space a lot more people are. I attended a talk around virtual kubelet. And like that was kind of a lot. I was just reading your section on nodes, and I was thinking it was kind of an interesting approach that I'm seeing people coming up with. But anyway, I think it's going to be helpful because yeah, it's kind of scattered all over the place. And then I know for the HPC to Kubernetes, I've sometimes pointed people to like a Slurm PowerPoint someone gave to kind of explain about the different ways of you could actually deploy Kubernetes and Slurm. So I think having just a place for all this is going to be helpful.
Cool. So I don't, I'm not looking for like specific feedback now, but I wanted to kind of share this formally and make everyone aware of it. And I can, of course, please keep giving feedback if you have it. I can kind of also share updates as I actually make the website live. I think it's going to be at like, I'm going to put it at convergecomputing.org or something like that. Um, and then what I'd also like to do is as there's sort of different initiatives to kind of dig into the details of things. So a lot of these things are fun and interesting. So talking about the design of schedulers and comparing between different spaces and algorithms that might, for example, influence the design of queue or something like that. I'll kind of put out calls into the working group channel like, hey, who's interested to work on this? Or who wants to who wants to help, who wants to look at this design document? Is anyone interested in, I don't know, making a video? Like there's going to be a lot of just kind of useful, interesting, and fun things to do. At least that's my hope. Anyway.
Excellent. Yeah. Yeah, and as you said, I think the working group, the batch working group in the CNCF side is also an interesting venue for you to share
Yeah.
because, well, our goal here is the Kubernetes core, to improve the Kubernetes core for batch applications.
Yeah.
And the CNCF group is a little bit more broad. Its scope is all of the CNCF projects, and to align I guess, the overall ecosystem. So this kind of what you're trying to do kind of falls more into the role of the CNCF group, but of course you can always get feedback from us as well.
Yeah, and I'm actually presenting there, but I want to be clear that like I'm a developer, and as a developer, I am interested in the development of those core Kubernetes components. But I don't think you can do that blindly and uninformed and kind of ignoring the cultural aspects, which is why I'm bringing this here into this working group as well. It's not to say that this will be like a focus or anything of this working group, but I think that we can still have awareness about it and kind of work together on these things. Yeah.
Sounds good. Yeah. I don't know if there will be any kind of mapping from HPC concepts to AI/ML, because those might vary a little bit as well.
I
So
mean,
we
oh
have
yeah, we don't
anyone.
do any AI ML and HPC, not we do a lot of that. I think there will absolutely be, and there already are. And it's I think actually I have a lot of thoughts about this. This probably goes beyond the batch working group, but I see a lot of what's emerging right now in kind of the batch and the scheduling ecosystem as trying to get around flaws in the core scheduler Kubernetes. That's not to say that I want to tear it out and destroy it, but I think a lot of technologies or a lot of projects that are oriented toward kind of what HPC does well, which is this basic job management and scheduling, could actually help with all those things. And so I think that'll be applied to ML as well.
All right. I think with that, I would like to keep some time for the rest of the agenda. Thank you, Vanessa. Andre, do you want to share your screen, or you want me to share? What's your preference?
Yeah, I think I can share. So if you can just give me the permission.
Yeah, of course. 1 second. There you go. Oh, not yet. Yes, no. Now you
Great.
can.
Yeah, thank you for the presentation, by the way, Vanessa. I think it was really exciting. I'm looking forward to see this glossary and just to see this doc. So just let me maybe start with introducing myself. So my name is Andre. I work at Apple, and also I'm part of the Qflow community. I've been there for the last almost 6 years. We're working on the training operator, the Khatib components for high parameter tuning, been involved in the benchmarking system, in notebooks and pipelines, so mostly all of these Qflow pieces during like these last years. So just to give the context, we've been discussing with the batch working group recently around the effort around job set and how we can collaborate. And maybe just before I can get started, I can give you a little bit of background on the history of the Qflow project. So just for everyone here on the call who just don't know about Qflow, Qflow is a project which was open sourced by Google back in 2017 to help data scientists, MLEs, and users to run ML workloads on Kubernetes. And initially, this project was just dedicated to run TensorFlow tasks and notebooks on top of Kubernetes. Back then, it was even not possible to create the custom resources. So set of folks trying to create an APIs and an easy way to run distributed TensorFlow tasks. And back then, like people see the value of Kubernetes and how it can actually help data scientists scale their experience. So I'm not going to speak about Qflow at all here. I'm just speaking about training operator. And training operator right now is just a specific component, like part of Qflow can be deployed as a standalone application, like similar to job set or like a leader or worker set, like an operator, which allows you to scale multiple training workloads. So it specifically like address the model training and the fine-tuning step of the AI/ML lifecycle. And only it kind of like allow you to create PyTorch jobs, TF jobs, Paddle jobs, MPI jobs, XGBoost jobs for the specific framework. And also like it has a similar like API structure, like a job set. Basically, you can define like the master replica, worker replicas. You can define the launcher replicas. So the idea is exactly the same what they have in the job set, but mostly like distributed across multiple frameworks. And right now, people use it for like creating distributed training jobs for the PyTorch. Like for example, this specific diagram, we can see that how people can use PyTorch job to like create all reduced type of strategy when basically they create the PyTorch job using the Python SDK, and then the operator responsible to scale all the workloads to do the all reduced type of training. And so the PyTorch is responsible to share the weights. So again, we're using the native PyTorch APIs and CLIs like a torch run to scale these resources and to make sure that the gradients can be shared across multiple workers. So exactly the same what we have in the job set. And similar to this, like in the TensorFlow, like we have a resource called TF job, which also basically the training operator is responsible to scale the appropriate resources and the setting the appropriate environment variables for the distributed job to make sure user can run the training on TensorFlow on top of Kubernetes. And so this is just a bit of a background what is actually training operator. And we recently started this doc to see how we can collaborate within batchworking group community and our community to see how we can unify effort. Because right now, the job set has been created, and this is like in a controller, which is basically orchestrate any type of the like ML framework. It can support like TensorFlow, it can support PyTorch, also it can support JAX. But we have like a few concerns that we want to discuss here on the call, specifically what right now doesn't support it and what is the right way for end users, especially data scientists and MLEs, to give these interfaces. Because the point is like for the last like 6 years, we've been struggling to connect the cloud native community and ML ecosystems, because these communities, so basically like MLEs and software, like data scientists, they don't know what is Kubernetes. They don't know what is kubectl, and they don't really want to understand all these pieces. They just want to easily scale their PyTorch code on top of like distributed compute, which Kubernetes offers. And for this type of thing, we need to like decide what we can do, how we can unify our effort to actually provide the single way for all of the users who want to actually choose Kubernetes as the primary platform to run distributed training, and provide them a unified interfaces to interact with, right? So just maybe give you, before I actually go through this doc, like any questions so far to me? Go ahead, Abdullah.
Well, actually, I was just planning to put my head in the queue. But I think I have one high-level comment.
Okay.
So Ray has been extremely successful because of what you exactly said, right? There is this Pythonic experience where
Exactly.
from the Python interpreter, they just code and then everything works. I'm fully on board with a project where we're trying to develop that, but with Kubernetes in mind as the main orchestrator. Ray wasn't that, right? Like Ray, they reinvented many of the things that we already have in Kubernetes,
Exactly.
right? Orchestration and so forth. So I love this. I think I'm just like being supportive here of the approach of like basically reinventing, I guess, what we have in Kubeflow, given where we are right now with Kubernetes in terms of how we support batch workloads and reimagine how the Pythonic experience is going to look like given the new things that we've developed, like
Yep.
queue, job set, the enhancements in job.
Exactly. Yeah, it's a good point, Abdullah. Like we've been experimenting with Ray, and we've been seeing like we actually we've done some benchmarks compare like native PyTorch and using Ray within Kubernetes. And I guess like the point is like yes, Ray is great, and Ray is like a simple way of how people can do end-to-end machine learning. But the problem is like if people want to be in the PyTorch ecosystem and if they want to use native Kubernetes control plane like the schedulers, API server, autoscaler, sometimes Ray doesn't give a lot of value unless you're using like Ray data, right? And having the similar concept of how we can stitch, for example, like Spark ecosystem plus PyTorch ecosystem together using native Kubernetes technologies is like what we try to achieve, like moving forward. And it definitely will be possible. The question is like, what is our, how we can make it like easier for all the users who want to utilize native Kubernetes workloads. Go ahead, Vanessa.
Yeah, I think this also goes back to some of the conversation that we had. I guess it wasn't a couple of weeks ago because this meeting is infrequent, but about how we can take basically existing workflow tools that we've identified people to use. So I think the conversation at the time was for like biosciences, but arguably we could extend that out to what are people using for machine learning, and then basically implementing a lot of kind of the handles to these different Kubernetes operators as the backend executors. So the users, the one that want to run their stuff in Python or whatever, their interfaces and interactions don't change very much, but the backend that's doing the execution is what we do. So I think the first question is, what are people using and comfortable with that they want to use? And how do we make a connection to it with what we want to enable them to use?
Yeah. Yeah, I think it's a good point. And we're also like kind of like observing that is why we created this Python SDK, like similar what I showed here. Like basically the idea is like data scientists, they only work with the Python. They have their PyTorch code and they're using Python SDK to actually, I don't know, create a container or maybe serialize their code to distribute workers. So this is what we try to do initially, right? So they only work in the Python environment. The question is right now how to make it more interactive because Kubernetes, like it's not really interactive tool right now, unless we have like a stateful set, right? And you kind of do everything inside the cluster. But we don't have like interactive, some sort of the batch experience today, right? So that is why people are afraid because like it's easy as Abdullah said, right? You can basically do whatever, like everything in your machine, and you can use the same API to do exactly the same on a large scale Kubernetes cluster, right? Yeah, so I'm totally on board with this, but I think we need to, again, understand from the API perspective, like what is the right way? Because there are several questions we need to answer. There are so many frameworks right now, and so many of them, I think, like emerging like very, frequently right now, especially booming how like AI is booming right now. And I think the question is, can we create a unified interface, which is job set, which will be unified across all of them, across all these distributed strategies and techniques Because today we have FSDP, right? Which is basically some sort of the mix between like data parallelism and they kind of like have a chart of the model on every device to train your very large models. So what if tomorrow they have new technologies with, for example, deep speed, right? So because I heard about people using deep speed plus MPI because it's like better when you have an appropriate kind of device configuration on your HPC cluster. And like, for example, for some use cases, it is better to train very large models compared to using just a PyTorch if your maybe HPC cluster is not configured for the NCCL, like NVIDIA Collective Communication Library. So there are a lot of different concepts which we need to like discuss. Can we create a unified tool and unified API which will, handle everything, basically? Yeah, so in this doc, like we try to, so we have few options, right? So the first option is deprecates the framework-specific CRDs and using job set completely, right? And it create the Python SDK on top. So the idea is to, we don't have TF job, PyTorch job, or like XGBoost job. We will just use job set for everything, and we will create like a Python SDK on top to simplify the submission of these jobs. Because the main problem is like data scientists, they don't really understand what is like, for example, PyTorch worker 00.pytorch. They don't need to worry about how to specify these appropriate environment variables, right? So they want to say, I have this PyTorch code, I want to scale to 3 workers, and you will do everything behind the scenes, right? That is why like we need to some sort of have an abstractions, right? And it's basically like working in the Python environment. So this is the one option. The thing is like we need to really make sure that all the features are supported. There are several things which right now don't support, like clean pod policy or other things. And we kind of like, we had a discussion with Yuki and Jono quite recently about do we need them? But the thing is like we really need to consider even in the future, there might be some features in the frameworks that it's not part of scope of the job set, right? So the point is we need to be really clear, like understand what is scope of the job set and how we can make this, additional adopters, right? And additional like additional functionality. So this is like the one idea. So another idea to use the framework specific CRD is a user facing. So this idea was proposed quite a while ago, because just to give you a little bit of history of how training operator was created. Before that, we have operator for every framework. So we have TensorFlow operator, we have PyTorch operator, we have like chainer operator, MPI operator. And the problem is because it's like just impossible to maintain all of them, and they kind of like share the common functionalities. We decided to create this common operator which will handle all the CRD, like PyTorch jobs, TF jobs, MPI jobs, right? And the idea was because by I think this proposal was created like around 2019. So by that time we don't have job set, and we just do everything inside training operator. But we actually discussed an option where we have some sort of front-end operator, which like data scientists and MLs interact, and we have like the infrastructure layer, like a job set operator, which is responsible to manage common resources, and the framework specific resources will be managed by these front-end operators to be like a framework specifics. So this specific use case can like cover like the MPI problem. Because I think like some of you familiar with MPI operator, MPI requires additional orchestration, like it creates the RBAC and the config map to run like MPI run command. And it's just not possible right now to run this MPI tasks within job set without additional orchestration on top. So this is another option that we have, and the API change. And this could be like, could be a temporary solution, right? Because like if in the future we understand that we don't really need this kind of like framework specific CRs, we can completely like migrate to job set, right? But it gives like a lot of power in terms of like extensibility, right? Yeah, and like the API looks very simple, right? You just basically have a specifics on your PyTorch job spec, like for example, like elastic policy, or maybe like a model URI, for example, if you want to have integration with model registry, right? And we have the specification for job set under the PyTorch job spec, so we kind of like have all of the features from like pod failure policy, run policy, all these like features that already supported on the job set level. Yeah, before I move on, let's go ahead.
Yeah, I have a question. How can we have such confidence that job set is this absolute abstraction that will be the one that is best to use moving forward? Because, you know, there's the new leader workers design, or sorry, it's LWS, I forget what it's called. But I think the other question, like, so I really like job set too. I built several operators that use job set, but it's not part of core Kubernetes. It requires installing another operator. So I've arguably stayed away from it. So my question, I guess I have two questions. You know, if job set is going to be this core feature that we're going to, you know, make as the base of many things, why is it just a Kubernetes SIG as opposed to something more kind of declared to be official? And then how do we have such confidence about choosing job set for the like the entire underlying unit of your new design? Because Kubernetes moves so quickly that like next year it's going to be something different.
Yeah, I think that's right. So I think like maybe yeah, go ahead, Ablo.
I could provide some context here as well. So at the end of the day, you will need to install some operator, which is the operator that will implement the PyTorch job, the MPI job. So one approach we could take, and I think I would be on board with, I would try to basically champion here is to have those as part of the job set operator, right? Like as one operator implementing all of them as several controllers, just like, you know, the Kube controller manager. Similar to what you have right now, the like, you know, the training operator. So job set would become that basically. It would be like one core API and then multiple APIs that are, you can consider them as decorators, like in our, you know, design patterns, right? Like around it, and would offer more functionality, right? On top. So I do dislike having, like, you know, the approach where job set is one operator and then all of these are going to be another operator, and then there is that, you know, operational toll that we're going to increase on the platform engineer. I would be supportive of having them in one operator. I think job set was to a great part incepted to address those common use cases. Job is that core API that we will have always in upstream Kubernetes. uh, I think pushing it upstream is not really in the best interests of this group because it will be extremely slow to evolve it. We are in a in a different environment right now. We want to act fast, want to develop fast, we want to iterate fast. Being in Kubernetes 6 allows us to do that. Um, so I guess that's my point. If those operators are becoming basically part of the job set ecosystem, then your concern of like having multiple operators is mitigated. Now the other question is, does job set represent the core, like the absolute, like the proper core functionality? I think the fact that, like, if we are going to visit all these APIs, we've got like PyTorch, TF, MPI, JAX, XGBoost. If we're able to model all of them using job set, then we have enough evidence that it does provide a reasonable abstraction here, right?
Yeah, I think that's right. I think like so. My question is like, if we decide to have this kind of, you know, extensions of job set, like, are we agree that job set will be extensible by the community? Because, like, for example, as I said before, right? If tomorrow will be a new framework, right? I know MLX. We want to run MLX on Kubernetes, right? Like, can we create in the upstream of job set support for MLX if MLX will require additional orchestration? Like,
Yeah.
how?
So my point here is like the extension versus not is an implementation detail.
Mhm.
I think we could have like an approach where you have a proper CRD, right? Like for MPI job,
Mhm.
but it's a secondary controller, right? That we have as part of the job set operator that would actuate and implement it, right? Again, similar to what you have right now with the training operator,
Yep. So
and it
basically,
would build on
yeah.
that. So that's the point.
And so basically these extensions will be part of upstream, you mean, right? Part of like the job set upstream repository, right?
Yeah, you basically we would, yeah, exactly. So job set would, like, you have the job set API, which is, we call it like the core API, and then you have those secondary APIs that act as decorators, right? Like they provide
Mhm.
specific functionality that I would actually argue that we may not need to provide like the full job set spec inside that, because we don't want to expose all of that, complexity to the user. We need to think about a simpler API. Ideally, I actually prefer not to even have a pod template, if we want to provide the ultimate simple experience.
Yeah, so this is like the problem, right? I mean, because like how we can if we don't like, like how we can create this top level like abstractions API, right? Because like as like the point of this front end operator is just to give a user a simple, API they can configure, like, for example, number of workers, and then we will populate the environment variables based on this value, right? For example, like we will populate the storage run commands based on a value that provided by the user, right? So user doesn't need to know how to specify master address, master port, right, and other parameters. And this is like the main point, right? Because the question is like, for this, if you're speaking about your specific use case, we need to completely redesign not like redesign, but we need to have this kind of like abstractions API on top, right? I'm talking about like Kubernetes API, right? Because
and that's the goal, right? Like, I mean, if we agree that we need to provide those simpler APIs that are much narrower in scope, right, and address a specific use case, then you have to have that. What I'm saying is that doesn't necessarily mean it has to be one-to-one with a job set. Job set is the main vehicle to implement that API, but we have more flexibility to include other things as well.
So my
Right.
question and my challenge, I think, would be before jumping into job set is to ask why this couldn't be implemented with just jobs. So for example, in job with an index job, when you set parallelism set to completions, you can do things like auto scaling, you can create the service. The way that I see it is that anything that I've been able to implement with job, I've also been able to implement with job set, but adding job set adds the additional complexity of needing to install the operator and also adds some features that are not good, such as it extends the name, the length of, for example, the service name, often to things that are so long that it can't be supported anymore. And I have to create artificially really small names of different, replicated jobs within that to support it. So it's not to say that that would be a bad decision, but I think if this is like a big change for this project, it first should be explored if it's possible to meet the needs with just job, and then only to move over to job spec when it's absolutely determined that that will not work.
Yeah, just
but like one thing here, the length of that is orthogonal to job set. That's a Kubernetes issue. Even if you use job, you're going to have to run to the same problem.
No, but you have a fewer things that are shoved into that domain name, and by way of that, you have a simpler user interface, and it's much less likely to happen. I have implemented 5 different HPC schedulers into this with job set, and I can attest to this for sure.
I understand, but the thing is, like, composing that, like, anyways, you will need to do something like this anyways, right? It depends on what exactly you use the names. At the end of the day, the length of it is controllable, and the fact that, like, the other thing here is job set adds some common functionality. It's like, right, like, you have to create a headless service. Allows you to create multiple jobs, but you don't really necessarily need to create multiple jobs. So I guess my point here is
it's trivial though to create a headless service on your own that doesn't have those restrictions.
No. It's, again, like, you could still choose a shorter job set name to create a smaller, like a shorter headless. I think this is a minor issue in my mind, like, to be frank.
Yeah, if I can just add one thing as well. If we want everything we're discussing here to be applicable for like large scale use cases, for big companies doing training across like multiple TPU slices or multiple racks of GPUs, some of the underlying layers lower in the stack, like some of the TPU like libraries, kind of make some assumptions about worker IDs and their role on each slice and their distributed initialization and so on. And so, for example, with like one index job, you can't just have every at least as far as I know, maybe Abdullah can correct me if I'm wrong, but I don't think with a single index job you can do multi-slice TPU training, because the indexes on one slice might not have like a worker 0. They might just be like 13 through 17 or whatever. And so that would limit your use cases to the smaller ones, basically, and kind of prevent a lot of like enterprise use cases. And that's one of the main things job set enables.
I think that's right. Yes. Yeah, absolutely. I think like so there are several things, right? So as you said, Abdullah, like if we're going to contribute everything directly to job set, the question is like we need to really determine like the purpose of job set, kind of like the purpose of this workload, right? Because like I can give you a specific example. Like for example, like this, we recently kind of like give user a simple ability to fine tune LLMs and to give them a one Python API which they run like called train, where they specify the model data set, trainer parameters, how many workers they want to run, and how many worker resources they want to use for these fine-tuning tasks. And then basically the user just run this API and we orchestrate everything behind the scenes. So basically kind of like downloading model from Hugging Face, we're getting data set from S3 or from Hugging Face Hub, and we have a predefined trainer. So data scientists, they don't need to worry about creating all these containers. They just basically run their simple Python API, and we will do the fine tuning behind the scenes on multiple workers. So the thing is like to support this with job set, we need the persistent volume template, which we have an issue. I know that Yuki shared this with me today. That's I think you opened almost like a year ago to support the index jobs and support persistent volume client template. But the problem is like where we should implement this such functionalities, because this feature might take a while, right? This feature might take a year or a year and a half to be implemented. So do we think that all this kind of like functionality should be part of job set upstream, or we think like we need to create an abstractions on top, right? Because how to distinguish like ML infrastructure and uh, basically the infrastructure components that we have within the job set, right? Um, so again, like back to my original point, how to define the scope of the job set by itself, right? So go
Yeah, I
ahead.
mean, I think the goal has always been like I was just going to mention that a lot of the Kubeflow things were created to support multi template jobs like masters and workers, which don't
Yep.
really fit very well with the job. Like and that's, I think it's very complementary to the job set, but I would say the goal, like if you can represent an index job with multiple parallelisms or whatever, you should use just a job. It's going to be much more performant. You don't have to create a second operator on top of job set. But where I
Yep.
see job set is this idea of two different types of templates for your jobs and then making sure that they can communicate to one another with the service. And I think that is kind of, at least to me, the goal. And then it's to also try and reuse a lot of the functionality in job. Like I think the biggest downside of the training operator is it doesn't actually use a Kubernetes job. So then you are either having to implement all the stuff like pod failure policy and
Yep.
success policies and failure policies, which I know that you have quite a bit of upstream requests for that currently. And I know that's kind of like our goal was like job is a pretty stable API, but there are reasons why you can't build everything with a job. And then the idea was, could we Russian doll kind of a thing for a job set to reuse the job?
Yeah.
And I think
Yeah. Go ahead.
that's just like kind of I think the goal of job set, and it's why I think this is a good conversation.
I think that's
Uh,
right. Like, yeah, yeah. I think like Kevin, we've been discussing this for like very long time to like reuse the job functionalities, because like the problem is all this code was created before job has all these features, like the success policies, right, and the pod failure policy. It was quite long a time ago. But like our initial goal to migrate to jobs when we have all these features that ML users basically require, right? But right now with the job set, like, initiatives that was a year ago, we need to think about like what is the right way for data scientists, right? Uh, because maybe having a one API, it's easier. It's definitely easier, right? And it's definitely easier to manage. The question is like, what would be the scope of this API if ML frameworks will require additional functionalities, right? As I said before, right? What if tomorrow PyTorch will have a new distributed strategy which will require, for example, I don't know, additional like RBAC, right? Or maybe like APIs. How we can deal with API? Are we going to create just extensions specifically for API? So maybe I
So
want to hear like, Abdullah, from your perspective, like if everything will be as part of job set upstream, how you think the API operator will communicate with those
Right.
APIs.
So
Mhm.
again, like forget about the extensions piece. You can think of job set as pod. Okay. Right
Okay.
now, when you're training operator, you're creating direct pods, right? Think
Yep.
of job set just like that, but it basically offers you all that functionality that you might have needed to implement anyways, like multi-template,
Yep.
right? Success policy, failure policy, all of these abstract concepts, right? Basically encapsulated in one API.
So what is
And
the, yeah, go ahead, sorry, go ahead.
yeah, and then you build on top of that. So basically, your PyTorch job creates a job set. It creates,
Yep.
for example, a secret. It creates a
Yep.
config map and stitches everything together, right?
Like basically what I show here, right?
Yeah, yeah. So exactly, that's what I'm saying. Like, and I
Sure.
think I put a comment there saying I like this approach. This approach, I think, is what we probably can provide value as we move forward, and build the ecosystem right around it.
Yep.
Again, the idea is not to try to restrict ourselves with the job set controller itself. Like it's not a callback like this the other option that I was proposing. You have
Mm.
another controller that have full control over what I need to do, right?
Mm.
But the
Yep.
only thing that it does is basically it creates this resource for you, which is jobs that handles most of common functionality that you need to do anyways, right? So one approach is to either do that or create a job directly. But then there are cases where you need multiple jobs because you need multiple templates. There are cases where you need a job, not just multiple, like a leader worker, but you
Yep.
actually need a job per accelerator island, right? We have that in like a Google Cloud. You have those like, GPU slices. NVIDIA is going to have the exact same thing very, very soon, right? Like they've already released it, where you have like each group of machines, they form one unit, right? And you will have
Yep.
multiple of them. And then you need to define groups of pods that land on each one of these islands and define communication patterns between them. Jobs
Yep.
allows you to have that abstraction where you can, okay, I need 10 islands, right? It creates those 10 islands for you. And I need 10 islands with one job that acts with a single pod that acts as the driver, right? So it provides those basic, common functionality um, that is not, I don't see it as restrictive as long as you build on top of it.
Yeah, that's right. I think like for the long, I mean, for the short term, there's definitely like the right, solution to see because like we definitely need to like have a new version. We have like existing users who are using the, for example, PyTorch jobs. Like I think last meeting, the folks from IBM were speaking about their usage of PyTorch jobs, right? So we know people who are using PyTorch job right now in production for the large scale use cases. I think like the point is maybe slowly as a first iteration, we should migrate to this approach and then like, see whether we can completely remove this additional, overhead on top of job set. Because like the problem is like, again, we don't know how ML will evolve in terms of the distributed capabilities, right? Like today we have like, fine tuning, right? Which is kind of like the mostly like adopted technique right now because of the cost of GPUs, right? And resources. Like not many people do training from scratch right now. And the thing is, like, I believe, like, AML life cycle will evolve dramatically, like next couple of years, and we just need to see how to stitch all these pieces together. But like again, as you said, I like that Kubernetes, like goes towards like more native supports for HPC and AML workloads, and like thinking about infrastructure and other pieces. But at the same time, we need to see how the ML, like ecosystem evolving, right, and how to make them more closer to the Kubernetes infrastructure levels, right? So,
Well, just one point here is
go ahead.
that think of job set as a building block and an
Yep.
implementation detail of that high level thing that we're building, right?
Yeah, that's right.
Like I like you I don't see it as something once you, for example, use or commit to, at least in the short term, is, oh, we're stuck here, right? That's not the case. And what I'm trying to communicate here is this API provides some common functionality that we can reuse. It's battle tested. It's been used at scale. It provides abstract functionality. It's not necessarily like we're not calling it a training job, right? It's a job set. It's basically an operator that allows you to create X number of jobs with some common functionality that we've noticed that is extremely common, right? And then you can build something on top of that to, customize it however you want. Add more resources to it on the side, right? And but the thing that I'm passionate about is to try to find this common functionality that way and try to push it downstream. So either you push it, like if we find some functionality across all these operators that we could push to job set or even push down to job, that would be great. And if
like
we build that
Elastic,
ecosystem
right?
close, if we build that ecosystem like close to job set and job, with like basically in Kubernetes 6, that would actually be, I think it would give us the opportunity to act faster there.
Go ahead, Vanessa. I think
folks,
go ahead.
We are out of time, so we need to wrap up. Maybe we can continue the discussion in the next meeting. But I think overall we have a path forward. I think the next step is, what's the next step? I guess you'll go back to Kubeflow training and present some.
Yeah, I think we need to speak with our leads and just to propose this kind of idea of like short-term migration of customers, who are using the PyTorch job within like job, like with the like V1 version, maybe have a V2 version where we're using the jobs and functionalities, right? And then just to see how it can support all the features like elastic policies, fine-tuning, right? And other like pod failure, because even pod failure policy will be extremely useful. We don't support this today in the training operator.
I think, I think we need to identify whatever is missing in both job set and job.
Yeah.
I had a question that was related to kind of how I can help as a developer. So just so I understand, those controllers that were in the left image, a lot of them exist. I know MPI job exists. And the idea is that you wanted to kind of do this design so that Kubeflow would kind of implement either all of those or all of them in the sense of job set. And you're saying that near term, you want to do the first, long term, you might want to do the second. So my question is, if I'm, for example, a developer of a controller like this, do you want support like now to kind of work on some, either the testing, the diagram on the right, or more testing of the diagram on the left? Because I think there's a lot of developers in this meeting now that would be interested in
I think we need to split between infrastructure and experience. So left is more about ML experience, right is more about infrastructure. I think if we make these distinct differences, it makes it clear for us where we should contribute, right? Because again, we really need to be data science facing, right? What they want to see from their API perspective, and they're not like Kubernetes engineers. This is what like we're observing for the last 6 years working with these ML communities. So
do you have a Kubeflow like meeting where
we have the working group training meetings. Also, we have the Kubeflow community meeting. So I can drop the link for the training meeting. Maybe we can discuss there like next time. And also, I will open this doc for a while, so feel free to provide your comments and we can continue discussion. So
maybe already put a hole in the agenda for the next slots.
Sure, I'll do. I think we should also discuss about MPI and how these pieces could stitch together.
I'll bump my item to the next meeting too. This was a really fun discussion. I enjoyed this.
Sorry they're taking so much time. But
it was great. I really appreciate it.
I guess we should consider extending the meeting to 1 hour. I don't know why we didn't that.
I didn't realize it wasn't 1 hour. You're like, okay.
Oh yeah, it is 1 hour.
What's going on?
But thank you all for joining. We'll see you next time. Please put the items in the agenda so we can follow up on this.
Thanks, Aldo. Thanks, everyone. See you next time. Bye.